In this video, I will show to you the derivatives of our circular functions. And not only that, I will show to you how the derivatives of this function come to be this way, using, of course, our set of rules for getting the derivative. So last time I showed to you the second set of rules for differentiation. And the new set of rules that I introduced was the rules on product rule and quotient rule. So we are going to use that, especially the quotient rule, to prove or to show the derivatives of some of your circular functions. So I have already shown this. The derivative of sine of x with respect to x is cosine of x. And maybe you can still recall it. We used the limit definition of the derivative to show that the derivative of sine of x with respect to x is cosine of x. The derivative of cosine of x with respect to x is equal to negative sine of x. The derivative of tangent of x with respect to x is equal to the square of secant of x. The derivative of secant of x with respect to x is equal to secant of x times tangent of x. The derivative of cosecant of x with respect to x is equal to negative cosecant of x times cotangent of x. And the derivative of cotangent of x with respect to x is equal to negative cosecant of x, and then you square it, or the negative of the square of cosecant of x. Show that the derivative of tangent of x with respect to x is equal to the square of secant of x. So you know, this one is among your fundamental identities. Tangent of x is equal to sine of x divided by cosine of x. And we will apply the quotient rule on sine of x over cosine of x to get the derivative. So this is the same as high over low. The derivative of high over low with respect to x. High is the function in your numerator and low is the function in your denominator. This can help you recall how to do the quotient rule. You square the denominator, okay? And then this is how you read it. Law di high, law, the function in your denominator times di high, the derivative of your numerator, minus high di law, the function in your numerator times the derivative of your function in the denominator. Okay? So d over dx of sine of x over cosine of x is equal to this. The square of law, and then law di high minus high di law. What is the derivative of sine of x with respect to x? It's cosine of x. Okay? And then minus sine of x times, what is the derivative? Okay? What is the derivative of cosine of x with respect to x? It's negative sine of x. Okay? And so that is minus negative, so it's going to be plus. Okay? So you're going to have a change in sign there because of the law of sines. So it's going to be the square of cosine plus the square of sine. And you know what this is equal to? This is equal to 1. So it is equal to 1 over the square of cosine of x. But that is the same as the square of 1 over cosine of x. And you know what that is equal to? That is equal to the square of secant of x. And so we have shown that the derivative of tangent of x with respect to x is equal to the square of secant of x. And we did it using quotient rule, using the derivative of sine and cosine, and using your fundamental identities. How about this? show that the derivative of secant of x with respect to x is equal to secant of x times tangent of x. Again, we will use a fundamental identity here. Secant of x is equal to 1 over cosine of x. And so we will apply the quotient rule once again on 1 over cosine of x. This is law di. The derivative of your function in the numerator, and that is equal to 1. 1 is your function in the numerator. And then hi di law. Next, the derivative of a constant function with respect to x is 0. Okay, so cosine of x times 0 is 0. Okay, and then minus the derivative of cosine of x with respect to x is negative sine of x. So again, because of the law of sines, it's going to be positive sine of x divided by the square of cosine of x. So the square of cosine of x, you can write it as cosine of x times cosine of x. And I'm just going to write this as a product of two fractions, okay? This one, I will separate this. Okay, and then you have 1 here, okay, 1 over cosine of x. So this one is equal to 1 over cosine of x times sine of x divided by x. And applying one more time your fundamental identities. This one is secant of x, okay? And this one is tangent of x. And so we have shown that the derivative of secant of x with respect to x is equal to secant of x times tangent of x. Let us show that the derivative of cosecant of x with respect to x is equal to negative cosecant of x times cotangent of x. So by now you already know how to do it. We will write cosecant of x as a fraction using your fundamental identity. It's equal to 1 over sine of x. And then we will apply the quotient rule once again on 1 over sine of x. And so the derivative of 1 over sine of x is equal to, okay, so our denominator is the square of sine, and then log di high minus high, this is your high, 1 di log. And the derivative of 1 with respect to x, that is just 0. And so sine of x times 0 is just 0. The derivative of sine of x with respect to x is cosine of x. And so it is equal to negative cosine of x divided by the square of sine of x. I will separate this into two fractions, okay? I will write the square of sine of x as sine of x times sine of x. And then look at this. Cosine of x divided by sine of x, and then you have 1 here. 1 over sine of x. So it's just equal to this. And guess what? This is cosecant of x. And this is cotangent of x. And so we have shown that the derivative of 1 over sine of x, which is cosecant of x, is equal to negative cosecant of x times cotangent of x. Show that the derivative of cotangent of x with respect to x is equal to the negative of the square of cosecant of x. I am not going to prove this. I don't want to take away from you the satisfaction of obtaining the derivative yourself. So I challenge you, show that the derivative of cotangent of x with respect to x is equal to the negative of the square of cosecant of x. And you will do that using quotient rule, using fundamental identities. So I'm going to show to you once again our set of derivatives for your circular functions.